the third topic that we are going to take today is small satellite launch vehicle. Small satellite launch vehicle. Why? This was a very interesting thing that has happened with the ISRO, and it also adds to one of the failures that we have been recently witnessing in ISRO, right? Like the failure of Mangalyaan to land properly on Mars, okay? Then we have this failure of EOS-03, as we talked about in one of our previous lecture on August 2021. We talked about, like, in the very same month last year, ISRO launched GSLV, which was carrying us Earth Observation Satellite 03. Now this satellite, this rocket was carrying Earth Observation Satellite 02. Okay, so this satellite was, however, let's look at what went wrong with the launch of SSLV. What happened was, the whole launch and the delivery of the rocket took place very fantastically, but still there was no rocket burst. The rocket took off very nicely. It placed the satellites into a specific orbit. The problem was that the orbits that it placed into was not the right orbit that it had to place. Okay, and that was basically due to a sensor failure in the terminal stage. We'll be looking into it in a great detail. It is very interesting, and I'll be explaining everything in great detail. The newest workhorse of ISRO, like ISRO has prior to this SSLV, this is SSLV. Okay, it is very, very important for every aspirant of any kind of government exam, UPSC, UPSC, any kind of government exam, to go through the history of ISRO, the kind of satellites that ISRO launches, the kind of rockets that ISRO has. Okay, so prior to this, India had, like ISRO had PSLV, okay, and GSLV. This is Polar Satellite Launch Vehicle, and this is Geostationary, Geosynchronous Satellite Launch Vehicle. Okay, there's a basic difference between PSLV and GSLV. Okay, most of the communication satellites, for example, okay, for example, a satellite carrying transponders for the television network, for example. So which orbit should it be placed? Now, if we look a bit into detail, like if we look into the what kind of orbits one should place and all these things. So this is Earth, okay? This is Earth, right? These are the orbits around the Earth. Now every orbit, it is not like you can fly and you can place an object in any kind of orbit. One needs to place, if one wants that a specific satellite rotates into that around the Earth or remains even constant at that place, then that kind of the distance from the Earth, okay, the distance from the Earth, this is called orbital distance. Okay, orbital distance. Okay, there are only specific orbits where our satellites can be placed safely, right? There are only specific orbits where our satellites can be placed specifically safely. If we remember, in our childhood, like not in our childhood, when but in around 9th 10th class, when we started studying the structure of an atom, okay, and then we discovered that the electrons, okay, this is nucleus and these are electrons, okay, revolving around. So electrons cannot be present randomly. They have to be present in specific orbits, okay? They have to be present in specific orbits whose momentum, okay, you don't have to remember all this, I'm just trying to make things clear, whose momentum is conserved. Okay, I will explain all this, do not get bothered by this. That means the problem here is, why does not electron exist here? Why have I made this orbit? or why I have made this orbit. Can an electron exist somewhere like here? That is not the case. An electron cannot exist there. Why? Because the momentum, okay, P should be an integral multiple of h upon 2 pi. Now this is very physics, a lot of physics that we don't have to get into. You don't have to remember, you can just ignore it all. But the point here is n is equal to 1, 2, 3. Okay, that means the electron can exist only in those orbits or in those locations where the momentum of that electron is a multiple of this value. Okay, h is Planck's constant, we don't have to remember it. Okay, what I am trying to say is that electrons can exist in certain specific orbits and cannot exist at other places. Similarly, here also the planets can exist in certain specific orbits only and not in other orbits. Okay, not in other orbits. What if we place it in other orbit, right? Let's look at what happens if we place it in another orbit. Okay, this is Earth. If we place it in this orbit, which is not a stable orbit. Stable orbits are those orbits where if an satellite is placed, it will keep revolving around the Earth. It will not fall into it. But if this is an unstable orbit, what will happen? That it will keep revolving, right? And it will start losing its energy and it will gradually spiral down into the Earth itself. It will fall into Earth itself. Okay? And that is why there are certain specific orbits where the satellite can be placed and not the other places. Okay, I hope you understood that. Now coming back to PSLV and GSLV. PSLV, GSLV, right? Now, PSLV means Polar Satellite Launch Vehicle. GSLV on the other hand is Geosynchronous Satellite Launch Vehicle. Geosynchronous means, for example, this is Earth, okay? If we place a satellite here, okay? Now Earth is rotating on its own axis, right? And it is revolving around the sun. It is also rotating on its own axis and it is also revolving around the sun, right? Now, if we place a certain satellite or a certain body at this point, and if it also rotates with the same speed as Earth, right? If it rotates with, like, if I have two people, one is A and other is B. If A runs with 10 km per hour, right, and B also runs with 10 km per hour, so we can completely safely say that A and B are stationary with respect to each other. Why? If both are running with 10 km per hour, then if they look at each other, they will see that the other person is not even running. That is called the relative velocity concept. Okay. That means if two bodies are going at the same speed in the same direction, then they will be stationary with respect to each other. They will be not moving with respect to each other. Similarly, there is a specific orbit. If we place any object in that orbit, okay, then it starts rotating with the speed of Earth. And when it starts rotating with the speed of Earth, what will happen? It will not go ahead of Earth. It will stay where it was. That means the area that it is focusing on, okay, the area that it is focusing on will always be the same area irrespective of what happens, right? That is called GSLV. These orbits are called geosynchronous orbits. And the satellites that we use to launch our the rockets that we use to launch our satellites into that specific orbit, these are called GSLV satellites, GSLV rockets, that is Geostationary Satellite Launch Vehicle. Vehicle means body that takes something to some place, and that is rocket. Vehicle means rocket. Okay, so that is a the height of such orbit is 36,000 kilometers. Okay, that is Geosynchronous Satellite Launch Vehicle orbit. But okay, the use of such orbits, the use is using communication satellites, okay, and for transponders, for example, transponders of our cable channels and all. Okay, because for the Indian satellite has to constantly provide services to India. Okay, so it has to remain stationary over India. This is somewhere India. It has to remain stationary over India. It does not has to. What if it moves here? So it will become difficult for communication, right? So that is why it always stays in its own place once launched. On the other hand, PSLV, let's remove it. On the other hand, PSLV, now this is very important to understand. These things are very, very important to understand. Once you understand it, you will be done with it. Now, PSLV are those orbits. For this example, this is again Earth. PSLV are those orbits. If a satellite is placed in this orbit, it moves constantly with a speed different than the speed of Earth, right? And that is a different advantage. Like remote sensing satellite. If you want some satellite that covers this Earth throughout the day for 4 to 5 times, so that we can see every portion of the Earth, then that will become what? A PSLV, Polar Satellite Launch Vehicle. It is placed at a lower Earth orbit. It is placed in the lower Earth orbit. Okay. Lower Earth orbit means an orbit below the geosynchronous satellite orbit. Understood? Now a bit of background. The newest workhorse, now PSLV and GSLV were two rockets. Similarly, ISRO developed SSLV, Small Satellite Launch Vehicle, a rocket that can be used to deliver smaller payloads. Okay. So this was the first flight of SSLV, the Small Satellite Launch Vehicle, and it was a failure in the terms that one of the sensor failed and the satellites were not being able to place into the right orbits. Although the usual failures of rockets are like rocket gets burst, or when the rocket is going through the atmosphere, it starts burning up, or some kind of technical malfunction happens and it burns up. But that was not with the case. Everything went smooth. But the case was one of the in the last, or in the terminal phase of the rocket delivery or the rocket flight. Sorry, one of the sensors went rogue. It stopped performing, and that led to the placement of the satellite into a different kind of orbit, which should not have been done. So the small satellite, this launch vehicle was carrying two satellites, satellite EOS-2, Earth Observation Satellite 2, and Azadi Sat. Azadi Sat was actually a satellite developed by the rural girl children of India. Okay, the rural school children, girls basically, they were trained into the development of satellite, and they also developed the ground system for receiving and communicating with these satellites, right? So they were trained into such by ISRO, and they developed such Azadi Sat. Okay, it was to celebrate the Azadi Ka Amrit Mahotsav that we are currently celebrating. And one of the sensors, what happened was, one of the rocket sensors malfunctioned and the satellite was placed into a different orbit. Actually, it was placed into an elliptical orbit, which was not intended. It should have been placed into the low Earth orbit. Okay. Now let's look at whenever you are reading all these PSLV, GSLV, SSLV, the first important thing that you have to look at is how many stages the rocket have. Secondly, what is the propellant that is being used for the rocket? That is, it is a solid propellant, or is it a liquid propellant? What kind of propellant is used? Okay. So this is the rocket. This is the first stage. First stage is the longest stage. It is 23 meters, 22.5 meters in height. Okay. This is the first stage. First stage rocket is that rocket which is used for most of the time, because a rocket has to fly at a very high speed to escape the Earth's atmosphere. It has to reach an escape velocity, right? The first stage is the largest stage that burns and takes it off the atmosphere of Earth, right? And after the gravitational pull, right? Where it cannot return back to the Earth. And then comes this second stage, and sorry, okay, and then comes this third stage, and this is the payload. This is the payload, means the satellites that we are sending are placed into this small module, right? These are only rockets. These portions are majorly filled with rocket propellant. So SSLV is a 3-stage rocket with solid propellant. Solid propellant, okay. Diameter 2 meter, 1.7 meter, that is not important. It is solid. All the 3 stages are solid propellant based, and it is what? It is a 3-stage rocket. It will be used to carry micro, mini and nano payloads. I have explained in very detail in one of my lecture that I took in August 20, 2021. You should go through that. What is mini, micro or nano satellites? And basically mini, micro and nano classification of satellites is based upon the kind of load or kind of weight they have. Okay, so it range from 10 to 500 kg payload. That is 10 to 500 kg satellites can be classified as micro, mini and nano. You can go through the classification within the whole section, but these SSLV, small satellite launch vehicle, was developed to carry these payloads which are micro, mini or nano satellites. Okay, EOS is a technology demonstration. Now we studied about what? The SSLV rocket. Now we are studying about EOS-02. It was a technology demonstration satellite. Technology demonstration means it is not going to be used for regularly, but it is going to be used by scientists to study what kind of it is a technology demonstration that we are able to successfully launch it or not. Okay, it is a test kind of. Okay, which will include agriculture. Like, it is an Earth observation satellite. Now Earth observation satellite is a kind of remote sensing satellite. Okay, that means it has to be placed in the low Earth orbit. Communication satellite has to be placed in the geosynchronous orbits, whereas the any satellite that is Earth observation satellite, it will be making 4-5 rounds of the Earth in one day, and that is why it has to be placed in the lower Earth orbit. Okay, SSLV is the smallest vehicle, only 100 ton. Okay, this is not important. It aims to cater to the market for launch. Okay, India recently started its own Antrix Corporation. Antrix Corporation is what? Basically the commercial wing of ISRO. Okay, and India's space launch, this whole ISRO and all these are commercially also very beneficial. Like, India launches a lot of satellites from other countries. Okay, it uses PSLV and GSLV, which have higher operating costs because of their higher payload capacity. Now India was trying this SSLV to make itself able to launch the smaller satellites, and the smaller satellites is a great market. Okay, so India was trying to demonstrate to the world that yes, we are able to launch a satellite in the lower Earth orbit, or a smaller satellites as well. So EOS-02 belongs to the micro satellite class, and Azadi was developed by students from girl students from rural schools. It contains 75 nano satellites. Okay, to celebrate what? The 75 years of our independence, that is the Azadi Ka Amrit Mahotsav. Okay, now this is the flight sequence. It took off well. SS1 ignition. SS1 matlab, that means the first stage of the rocket. It went very well up to here. Now VTM ignition 1.64.20 second. What happened was the rocket went very well up to this place. Okay, but there was a sensor that had to be deployed, and that sensor would have picked that sensor. If that got activated, it would have provided the rocket boost so that the satellite could have launched into the right orbit. But the sensor malfunctioned, due to which the satellite was placed into some other orbit, because the sensor failed, due to which the rocket boost did not happen, due to which the satellite was not able to take off into a higher orbit, that is the lower Earth orbit that it was to be placed, but rather it got placed into an elliptical orbit, right? So the ignition and everything was good. The failure happened in the terminal stage. Okay, now this is a question from UPSC. Satellites used for communication relay are kept in geostationary orbit. The very first thing that we discussed, The satellite is said to be in such an orbit when, okay, the telecommunication, in the very starting I said that telecommunication satellites are placed in the geosynchronous, geostationary orbits. Geostationary orbits are those orbits which are where if a body is placed, it will remain stationary with respect to the earth. It will move with respect to the earth at the same speed. That makes it geostationary, right? Stationary with respect to the geo or earth. A satellite is said to be in such an orbit when the orbit is a geosynchronous, the orbit is circular, the orbit is in the plane of Earth's equator, the orbit is an altitude of 22.236 kilometers. The first is the orbit is an altitude of, it is 36,000 kilometers. That means this is not correct. Now you can eliminate 4, 4, 4, 1, 2, 3. That is 1, 2 and 3 are correct. Let's look as to what are geostationary orbits. Now you can see here, this is Earth and 35786 around 36,000 kilometers. This is called geostationary orbit. This is called geostationary orbit, and you can clearly see that it is in the plane of equator. Plane of equator means equator lies just below the orbit. Equator lies just below the orbit, right? And this is not important, but I have still taken for the sake of information. Since the satellite orbit, the orbit is very far from 36,000 kilometers away, are we launching our satellites directly to that place? Actually, no. We are using instead geostationary transfer orbit. This blue orbit is an elliptical orbit. This is called geostationary transfer orbit. An orbit in which if a body placed automatically gets transferred into the geostationary orbit. Okay. So this is now you can see we have to provide propulsion for only this yellow part, okay, or green, I don't know what it is. It is not very clearly visible from here, but you can see for now we have to provide propulsion system only for this place. After this, it will automatically drift into the geostationary orbit. So this is geostationary transfer orbit, the blue one, okay, elliptical orbit, and this is the geostationary synchronous orbit. Yeah, geostationary orbit, that is circular. See, geostationary in the red, it is circular, it is not elliptical, right? Geostationary transfer orbit is elliptical. I hope you understood this whole very interesting thing. If you still have any questions, please connect with me into the comment section, right? I hope you understood this. This was very interesting as well. And it is very important from UPSC point of view, because UPSC is this is one of the very favorite parts of UPSC.